Let's go over 2.02 quiz, some practice problems that are extremely similar to what you would see on the quiz. So first is an example for question number 1. After observing this pattern, Fisher made a conjecture for the next number in the pattern. So for the pattern, it goes 7, then it goes to 12, then it goes to 17, then it goes to 22, then it goes to 27. So which number was most likely his conjecture, his guess, remember conjecture is an educated guess based on what you've seen, for the next number in the pattern? Notice that it goes from 7 to 12, which adds 5, goes from 12 to 17, which adds 5 again, 17 to 22, which adds 5 again, and 22 to 27, which adds 5. So you can see it's adding 5 each time. So we would continue this pattern. 27 plus 5 gives us 32. So that would be a good conjecture, a good educated guess for the next one. Now what about this one? Given that that angle A and angle B are supplementary, Kim conjectured that A is congruent to B. Remember, supplementary means they add up to 180. Congruent means they have the same measure. Which statement is a counterexample, something that proves this statement wrong? So we need two angles that might be supplementary, but are not congruent. Well, here's two angles, 90 and 90. They add up to 180, so they're supplementary, but they are congruent, so that doesn't prove her wrong. Then there's angle A and angle B, which are congruent, but they're not supplementary. They're complementary. They add up to 90. That doesn't help us. A is 60 and B is 100. Well, those add up to 160, so they're not even supplementary, so that's not going to help us at all. So hopefully it's D. Let's see if it is. Angle A is 50. Angle B is 130. Those do, in fact, add up to 180, and they're not congruent, so that's a good counterexample. That's something where we can prove someone wrong. That's essentially what you're trying to do with a counterexample. Someone says something and you say, well, that's not true because what about this? So if I said, it rained every day this past week, and you said, no, it was sunny on Tuesday, that's a counterexample. Something that you can show to prove someone's statement wrong. Question 3, this is just a hint. It's going to show you a couple statements and ask you which ones are inductive reasoning. We talked about this in our lesson over 2.02, but inductive reasoning is essentially an educated guess based on what we've seen or experienced, not a decision or an answer based on facts or knowledge of math or anything else. So it's not, well, I know that all three angles in a triangle add up to 180 degrees, so I can solve this problem. It's not that. It's like, I've seen 3 trees in the neighborhood and they were all green, so all trees must be green. Even though we know that there are, yellow trees, red trees, all of that. But what it is it's an assumption, a guess, based on what you have seen or experienced, not based on rules or laws or anything like that. So just keep that in mind. Question 4, you're going to see a pattern, and you're going to be asked to continue it. Look for a method to the madness. See if you can figure out what's happening from one shape to the next. And if you can't tell what's happening just in between 2 shapes, zoom out a little bit. Look at 4 shapes. See what's going on as you go through 4 shapes or 4 numbers or whatever it is. And then you should continue it. The next shape or number or letter or whatever's in the pattern should fit with the others that are already there. So double check yourself if you make a guess. Finally here we have question 5. It says, given that x is a positive number, aka it's not negative, it's greater than 0, Paige conjectured that x squared is greater than x plus 4. So we need a counterexample. Again, something that will prove her wrong. What about 4? 4 squared greater than 4 plus 4. Well, that's true, because 16 is greater than 8, so that actually proves her conjecture. We're trying to disprove it. Negative 2, that's not helpful because we said x is positive, so we can ignore that. What about 2? 2 squared, is that greater than 2 plus 4? 2 squared is 4. 2 plus 4 is 6. 4 is not greater than 6, so this is a counterexample. We could say, well, that's not quite true, Paige, because if I plugged in 2 for x, then that statement would not be true. And so you can see 3 would make it true. 3 would not be a counterexample because 3 squared greater than 3 plus 4, well, that is true. 9 is greater than 7, so that's not going to be a counterexample. That would be something that would prove her point. We are trying to disprove a point when we are talking about a counterexample. Awesome job, and good luck on your 2.02 quiz.